Whether you're just starting your PCB design journey or have been doing this for decades, routing PCBs remains one of the most time-consuming and iterative tasks in the design process. Routing alone eats up about 30% of the total design time. No wonder engineers have always dreamed of the perfect autorouter. But here's the thing, solving that problem isn't simple, which is why the industry is full of skepticism. You've probably heard the old mantra, when it comes to autorouters, the setup takes longer than routing by hand. While autorouters have improved over the years, it often comes with a steep learning curve. The configurations can be so complex that even experienced engineers need months to master them, let alone entrepreneurs or EEs who are just getting started. That's where Flux's brand new AI Auto Layout comes in.
Activate.
In this video, I'm going to show you AI Auto Layout routing, what amazing advancements we've made in the winter update, a complete guide on how to set up your board for the best results, and finally, how to run auto layout. Traditional autorouters treat routing like Boolean geometry problems. If you give them a dense enough rule set and enough time, they'll connect pins, but they don't understand placement intent, manufacturability, or what a reasonable layout looks like. The result is familiar: tangled paths, excessive vias, and a lot of cleanup time. AI Auto Layout approaches routing differently. It's a reinforcement learning model trained on a large set of professionally routed boards. Instead of requiring complicated board-by-board configurations to get usable output, it uses training to make routing choices that resemble a thoughtful human-like first pass. That said, it's not designed to fully auto-route every class of board without guidance. You should still expect to route certain categories manually. The workflow that consistently succeeds is an 80-20 split. Set up your board, hand route the most critical nets if they are present, then AI Auto Layout completes the remaining bulk routing. Let's see what changed in the winter update. This release focuses on speed, reliability, and improving intelligent routing decisions by the model. First, the model converges much faster, about 4 times faster than the previous beta. Practically, that means on well-prepared boards, you should see a usable first pass in tens of minutes instead of hours or longer. Second, there are several new artificial intelligence layers which are automatic by default. These provide better context and feature support, like net types, where sensitive nets are routed earlier with cleaner separation and noisy nets are handled more cautiously. There's also relaxed clearance of traces, improving ground port continuity, which reduces crosstalk and improves signal integrity. Overall, the winter update makes AI Auto Layout faster to use, cleaner in its routing decisions, and more dependable on 2, 4, and 6-layer boards. Let's dive into the step-by-step process that you can follow to quickly set up your board for routing with AI Auto Layout. Once your component placement is finished, preparation happens in 2 stages. Stage 1 is the general layout setup. The setup you do whether you are routing manually or with AI. This stage is about making the board physically routable with proper electrical and physical constraints. Stage 2 is auto layout prep. This is where you'd add more information and features to the project, which provide more context to the AI model. It's possible to route your board without this stage. However, the results are less likely to be manufacturable after the first run, as well as more expensive. After those 2 stages, AI Auto Layout will run with its best performance. Let's look at stage 1, setting up your board for manual or auto layout routing. To select your Stackup, click on the Object Tree tab, select Layout in the tree. Navigate to the Layout Rules dropdown in the inspector, and click on the pencil icon to open up the Stackup editor. Once in there, you can select any number of commonly used Stackups. It's important here to ensure that you select 1 or more layers to be your ground plane. By setting a layer as a power plane, the agent avoids routing on it. This makes certain traces on adjacent layers have proper ground coverage, reducing crosstalk and opening up return paths for your signals. In the same Stackup editor, you can add your vias. To modify object layout rules, navigate to any object within the object tree. Then navigate to the same layout rules dropdown in the inspector. There you can manage existing rules or add new rules which only apply to that object, like protection rule for polygons. Simply click Add, search the rules pop-up, click Add again. To create rule sets, which are groups of layout rules that can apply to multiple objects, you open the Rules tab and select Create. Enter a name, then a description, and then enter your selection criteria. This is what you use to select objects from your PCB. Then you add layout rules that apply to them. To find out more about selection criteria, take a look at this docs page. You can also copy and paste existing rule sets using copy and paste commands from your keyboard. And even better, in order to avoid having to create rule sets on your own, we highly suggest using the available template rule sets, where with a simple few clicks, you can set up your board with all the most common rule sets and assign them to the nets and objects you need. The second stage of the setup process addresses these areas specific to auto layout routing context. Zones and Flux are used to void the automatic ground fill on all or specific layers. We also recommend their use for auto layout in order to prevent the model from routing underneath sensitive or noisy components. To add a zone, you simply right-click on the board, select Add, select Zone, and then you can resize it by selecting and navigating to the Layout Rules tab in the inspector. This model is not currently capable of resizing trace widths for nets. It also cannot alter the keepouts on net copper. This means that you need to intervene before you run the job or after the job completes to add neck downs or fanouts when large trace widths like power need to connect to small pads. Similar to our previous model, the focus of this agent has been on reliably routing the most common signals which our users face on their projects. We recommend routing high-speed, sensitive analog, as well as sensitive or high-power copper manually before the job begins. When it comes to leveraging the most out of our auto layout, it's important to use all the performance boosts you have available. A new and incredibly powerful feature in this update is net types and net priority. Net types are found in the schematic. If you click on a net and navigate to the Properties dropdown in the inspector, you can add a net type, which will influence the routing behavior of that net. And thanks to an additional layer of AI intelligence, this incredible feature does not require manual intervention if you don't want it. Flux will automatically infer the net types using an inference agent behind the scenes whenever you begin a job. So if a trace does not have a net type, one will be assigned. Now, we're ready to run AI auto layout routing. With a single click, the tool gets to work. It begins by gathering all previously configured elements and runs them through a DRC checklist to ensure compliance. The results of these checks can be found in the Systems Check dropdown. Here is where you will be notified of any issues in reference to your configuration from setup. Of note, you will see trace intrusions on polygons, protected layers and polygons, as well as which nets, if any, are unable to be routed. You'll also notice the first few routing iterations that appear will only have nets with higher priority net types. The first several iterations you will see make large sweeping changes. It's likely that these may leave issues like air wires, inadequate ground reference, and overall lack of cleanliness. But don't dismay. As the AI progresses, it makes smaller and smaller adjustments while converging on an optimal solution. What's great about this process is it's completely flexible. If you like an option early on, you can step in, apply that solution, and refine it. Or you can let the AI continue to iterate towards the optimal, converged solution. And that's it. You're ready to run your first board using Flux's AI auto layout routing for free right now in Flux. Flux is an EDA tool designed to take the hard out of hardware, and it's evolving faster than ever. If you enjoyed this video and want to see more tutorials and walkthroughs, be sure to like this video and subscribe to the channel. Thanks for watching, and I'll see you in the next one.